Hey Coyotes, welcome to Lab 3, Form 8.1, Jumping Vertical Power. So similar to the Lab Form 7.1, the first thing you need to do is you need to convert your kilograms into newtons. So we are dealing with 75 kilograms, which if we do the calculation into newtons, we're going to multiply this by, we are going to multiply this by 9.8067. Which, when we do the math, we get a 735. I lost my mouse. 735. So 735. For this example, we will say their standing reach was 89 inches. Recall what this kind of visually looks like, and the individual is standing, and by the way, this is in the context of the Vert Tech, which is the doohickey thing. It kind of looks like this, and it has the little weather veiny things that kind of stick out of it, and the individual has to reach up and slap it. So when they're doing their standing reach, they're literally standing with their hand up and they're trying to reach, and that's kind of their starting mark. So we know their beginning height of 89 inches, and then the math of the numbers with their attempt. Again, this machine only measures in inches, so we're going to start with inches and then have to do probably some conversions later down the road. Do we need to do all the conversions of each trial? We'll show you kind of what's going on with that. So their first attempt, they got 108. The second attempt, they got 109. Their third attempt, they got 109 again. And their fourth attempt, they got 109.5. Now, your book talks about how many attempts, but honestly, the way I've always done it is they go until they miss. And so you can kind of see first trial, that's what they got, and then they got a little bit higher, and then they kind of stuck there, and then they had one final attempt, and that's what they got. So best overall is that. So 109.5 in inches. And with this information, now we're able to do some subtraction. So we would take the starting number of 89, and then we would subtract it by 109.5. So if we go ahead and do that, 109, the highest number possible, so we have a positive, subtract 89, and we get 20.5. So that was actually their vertical jump. And then from there, we're going to go from inches to centimeters, and then we'll figure out the vertical distance, or excuse me, the vertical difference. So the conversion factor from inches to centimeters is going to be 2.54. So we're going to do the multiplication for that now. So I already have my 20.5 from last time, and we are just going to times it by 2.54. Good number to memorize, and we get 52.07 And then to get the difference, this is really simple. We're going to go ahead and we're going to divide by 100, because now we're dealing with, this is cut off, but there should be a meter right there. We're going to divide it by 100. And we get 0.5207. And we're going to go ahead and take that 7 and drop it off because it's above 5, and we're going to round it up to 1. So we're going to report it as 0.521. Meters. So now that we're in centimeters, because we're dealing with things that are in tenths and hundreds and thousands kind of places now, it's intuitive that we can just kind of move it up by dividing by the 100 to get into the meters. Now to kind of finish off, we're going to calculate absolute power and relative mean power, or absolute mean power versus relative mean power. And we're dealing with two different equations, the Lewis equations and the Sawyer equation, which is this one down here, and it's cut off as well, but that's what this one is. So this is when we start having a lot more fun and with dealing with some root signs. They're easy. I'll show you how to set them up in the calculator, and you won't have any issues with this. We've done most of the hard, heavy lifting stuff already. Now, again, just kind of fill and go. So we know what the body mass is in newtons. It's 735. And we need to know what the difference is in meters, which we do. So we just need to put 0.521. And then from there, we can figure out the watts. And then remember the absolute versus the relative. Anytime you see relative, we're dealing with some kind of body weight factor that's put in there as well. So we have this. So to get to the Sawyer equation, you need to finish the Lewis equation first to figure out watts, which will go right there. And then we'll go ahead and fill this in already. Kilograms, what are we dealing with? We're dealing with this weight factor now, 75. So really what's left is we need to figure out what the watts are up here. So if we go ahead and just kind of pull up calculator.net, we have our nice little handy dandy calculator, and we can set this up for our absolute mean power. So the first thing we need to plug in is 2.21, and we're going to multiply it by newtons. 735, and then do not worry about this multiplication. All you're going to do is do the root symbol. And then you're going to put the difference. 0.521, and that equals 1172. 1172. So when we're figuring out the absolute power, we end up with 1,172 watts. And then we know we're dealing with watts, so this number is going to be a little bit heftier than normal, and it makes sense. And I'm going to just use my other calculator because we don't have to worry about those other functions. And also, it's because it went down here into the void of my computer. So this is what's available. So this is what I'm going to use. And simply divided by 75, and what do we get? We get kind of a weird long number, but we can just hash it off because we look at the 10th spot into the 100th spot. It's lower than a 5, so we're just going to keep it 15.6. All right, so let's go ahead and work on the Sawyer, Sawyer or peak power. First thing we need to do is we need to figure out what the vertical jump is in centimeters, and we already did that way back then. This was 52.1, so we'll go ahead and write 52.1. And we know what the kilograms are, the weight, 75. And to jump ahead a little bit when we look at the relative, because we're dealing with this now, where there's actually a weight piece to it, we can just kind of throw that in there as well, so 75. So kind of working our way across, first we're going to work within the brackets. We're going to multiply 51.9 times 52.1, and then separately do 48.9 times 75, and then subtract 2007 from that. I point that out because sometimes students will they get this far down into it and they forget about the 2007, which throws off their watts in the end. All said and done, when we do this in the correct order, we will get 4,364. And then that number slides down here, 4,364. Oh, the joys of writing with mouse. And then we just divide it out, 4,364 divided by 75. And what do we get? We get 58.2. So it's pretty straightforward. Your guys' lab assignment numbers will be a little bit different than these ones, but I think it's worth walking through it so you guys kind of know which goes where and what to do so that you get the best outcomes possible. So if you have any questions, email me, let me know.